He works with a lot of different kinds of partners, governments, nonprofits, health systems, and other partners. So we're excited to hear more about this latest work.
Awesome. Yeah, thanks, Angela. So today I'm talking about evaluating decision-making under uncertainty by large language models. And I think the starting point for this is that language models are often now, I think, being put in these kinds of settings that we're talking about that require bridging predictions and interventions. And even though that is sort of methodologically very different maybe from building a statistical model, part of the pitch of this talk is that some of these same ways of thinking about what problem the model is solving are still very helpful for evaluating and understanding its behavior and hopefully improving it. So as an example of one of the specific kinds of settings we might have in mind, this is an example of a very kind of simplified version of like a medical interaction, clinical diagnosis. The patient shows up, they say, I have some problem, my stomach hurts, and the language model has a bunch of different options for how it could try to reply, right? It could give them just an answer, right, a diagnosis. It could ask them questions, try to seek more information. It could defer, right, tell them that they have to go talk to their doctor. And what the model ought to do depends on a lot of unknowns about the patient, right? They're not present in that sort of like initial context that it sees, right? So this is why we think of this as decision-making under uncertainty. And so certainly it would be really appealing if language models could navigate this kind of interaction well, right? It would like really dramatically expand access to this kind of like specialized medical information and advice. And so this is a kind of workflow that lots of people are trying to build, both for medical applications, but also for example, human services, right? Like helping people navigate what kinds of services they might be eligible for. Lots of things like this kind of on the horizon. And so then the feature of these tasks, right, is that doing them well requires a lot of things, but it certainly requires both reasoning well about that unknown information about the user, and then also about understanding goals, right? Like having a correct understanding of a utility function that describes what are more or less desirable states of the world. And that creates then also a lot of places for things to potentially go wrong. So some of my thinking here is motivated by a specific example, which is a project that a lot of people, a lot of collaborators have been working on in the last year and a half or so, which is aiming to specifically build language models to answer questions from pregnant patients in India, right? So to provide medical information during pregnancy. And so, we're working with this sort of consortium that has this WhatsApp-based platform that right now provides very scripted health information, but we'd really like to be able to provide, more like, contextually specific, personalized questions just or answers to questions that people have. And so, we went through this process of, building a retrieval augmented generation, system with the goal of being able to answer kind of like lower stakes questions, for example, about nutrition, while escalating more pressing issues to the health system. And we've sort of, recently started to do like sort of a pilot test of this. But in this process of building the system and doing offline evaluations of it with human medical experts, there were a couple kinds of issues that were very commonly raised. One of these, the first axis here is, in this understanding of uncertainty. So for example, the interpretation of, lots of kind of common symptoms during pregnancy really depends, importantly, on characteristics like gestational age. How far along in pregnancy is the patient? And when that information wasn't available, the model wouldn't really ask for the information. It wouldn't, hedge its answer somehow. It would just give an answer that was implicitly only correct for some range of gestational ages. So that's one axis. I think this echoes a lot of other evaluations in medical settings have observed similar kinds of failures. And then the other axis is in understanding of preferences. So for example, the model seems very kind of willing to risk basically like scaring patients with these sort of like unlikely but severe scenarios in a way that human medical experts thought was just like an inappropriate way to communicate with patients. And so so we did what I think a lot of people do and sort of, try to, patch all of this, resolve these issues with, lots of kind of like domain-specific scaffolding of various kinds. But this really, leaves me wanting a more principled way of understanding these kinds of capabilities, right? Being able to break down exactly where and how and why they're doing, well or poorly at decision-making under uncertainty. And so this is the piece of work that I'm going to talk a little bit more about today, which is led by my PhD student, Karan Yaman. So to set a little bit of formalism, we're going to work in a decision-theoretic framework that I think is very familiar after a lot of talks here, where a decision maker faces an unknown state of the world that's drawn from some prior. Yeah, Emma?
Just a quick clarification, if you go to the previous one, when you talk about capabilities, are you thinking of evaluating existing systems, or are you somehow thinking like fundamentally for LLMs, do they have certain capabilities? Like, imagine you could change the algorithm and then you address a lot of this, or you could say something generally transformers can't do this.
Yeah, I'm thinking about evaluating specific systems. Thanks. So in terms of the formalization, unknown state of the world, drawn from some prior distribution. The decision maker does not get to observe that state directly. They do see an observation, X, which carries information about it. And their goal is to select an action that minimizes some loss function in expectation over the conditional distribution of the state, given what they actually got to see. So now this task involves these two different objects. It involves both the factual beliefs about the world, which here is the decision maker's posterior over the unknown state, given their observation, right? That's what's controlling this expectation. And it also involves their normative preferences, right? Like their loss function about what states are, what actions and states are more or less desirable. And so what we're going to do here is build a framework that elicits models both beliefs, right? So there's this subjective probability of about the state of the world, and then it uses that to estimate the model's kind of like implied loss function, right? So in a revealed preference sense, what loss function would explain its actions. And the motivation for doing this is that we want to be able to attribute suboptimal performance to specific kinds of errors. So instead of just getting the signal at the end of the process, which is, no, the model didn't do the right thing, we want to be able to give a much more granular description about these intermediate components to be able to attribute loss to specific kinds of errors in belief formation or misalignment of loss functions to get this more detailed kind of understanding and hopefully be able to improve the system. And I do want to kind of acknowledge at the outset that there's something kind of weird about talking about models in this way, right? Like, what does it even mean to ascribe beliefs or utility functions or any of these constructs to a model that's just sort of this pile of weights sitting in a data center? And at least my starting point for thinking about that is that it is non-trivial to define even what it would mean to articulate a belief from a human. So maybe we can start there with a little bit of the thought process, for example, in the sort of literature in behavioral economics and psychology that thinks about belief elicitation. So first, why would we want to elicit beliefs from people? So this is a quote from a reference on belief elicitation. I'm not going to read the entire thing, but basically it's saying that we want to elicit beliefs because we want to understand the reasons that people have for making choices, right? Not just understand their choices, but understand more of the mechanisms. And so, for example, if it's referring to this bargaining game where I decide how much money to offer to a counterparty, and if you see that I offer my counterparty a lot of money, maybe that means I'm altruistic, right? Like my utility function encapsulates something about that other person having money, or maybe it just means that I have some beliefs that the amount of money I get will be maximized by making a generous offer. And then that would imply different things about how I would react to potential interventions or act in other circumstances. So this is why we might want to sort of like decompose behavior in this way. But it is pretty difficult to define what it means for a human who is not sort of a Bayesian agent necessarily to to hold a belief about a subjective probability, especially in a way that is distinct from the process that is used to elicit that probability. And so as a consequence, there's not sort of a great resolution to this, right? Like there is no sort of clean way to compare different ways of eliciting beliefs. And so this is not something I think we can expect a sort of clean answer to. It's more a process of sort of triangulating between different kind of ways of understanding the system and hoping that we get something that is kind of consistent and useful. So with that said, the motivation for then doing this for language models is, I think similar in some ways, right? It's to better understand and intervene in the system by disentangling mechanisms that might underlie, the sort of the observed behavior, and to offer some benchmark basically to a normative ideal for what we think the ideal decision maker would do in this setting along all of these different dimensions. I also want to sort of, position this against, some like a related line of work here, which is that there's this sort of like, growing like sequence of papers that are asking whether language models exhibit various kind of like behavioral phenomena, right? Like, risk aversion, different kinds of cognitive biases, all of these things, typically by taking tasks modeled on behavioral lab experiments that, people have been asked to do, and then prompting the language model to sort of fill out the same questionnaire, right? And so this is often like a choice between lotteries where you win different amounts of money with different probabilities, and we ask the language model, to sort of like fill out the same questionnaire. Yeah, question?
Terms, and I'm wondering why choose the term belief? Like, I totally understand your desire to try to disentangle these two issues, but like, why not logic? Or like, I'm just wondering about the term belief because it brings a whole bunch of baggage that I think is specifically human to.
Yeah, no, this is a really good question. I think. So part of the reason is because then in the sort of the normative like framing of the problem, right, is like the decision-theoretic problem, right, then that's like maybe we could just call it subjective probabilities instead and like control F that everywhere for beliefs, and maybe that would be that would be better. Like I'm open to that. But then I do think that that's like often then people use belief to sort of mean the whatever sort of like construct related to a subjective probability that's involved in the agent's decision making. But
I guess I'm pushing on the idea that they have anything other than a seductive blah 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 blah. Do they like?
Yeah, no, I'm very open to the idea that we should collectively like adopt a better kind of like terminology here. Yeah, Deb.
Did you have constraints in terms of which language models you could actually use? Like for this project, you said you were working with a particular nonprofit and interacting with. I'm not sure if, like the motivating example. I was kind of curious if when you were exploring that, you had constraints in terms of you couldn't use specific vendors versus open source models versus models that were maybe smaller and more efficient versus models that required a lot of inference compute. I'm just kind of curious if there's constraints in terms of the range of language models you're kind of exploring for this work.
Yeah. So I think to your question, so these are like kind of two different pieces of work in the same, like in the sense that like the motivating application is not what I'm gonna like directly do this on. But I am happy to talk about like specifically like the like engineering trade-offs and like constructing models for that system. Maybe we can talk about that later.
So back to the definition of what's a belief, right?
Mm-hmm.
When you use the word belief, you kind of implicitly making the assumption that it's something at least not fleeting. It's something you can solicit. Mm-hmm. It's something not just changing depends on what prompt you put in.
Yeah, well, so this is where, like, so I think that maybe belief is a more kind of like useful construct if there is a sense in which you get, sort of maybe like somewhat consistent answers across different ways of attempting to elicit it. But whether there is just like a single thing that exists independently of the elicitation method, I don't really know. Yeah, Sammy?
Just because now I've become a little bit confused. For the rest of your talk, is it okay to just think of belief as a probability distribution over states of the world in your decision theoretic framework? Is that what you're implying by belief?
Yeah. Beliefs. Yeah. We should like.
Okay.
Yeah. Let's just talk about like subjective probabilities maybe instead.
Okay, so it's just probability distribution over possible states of the world.
Yeah. Right. So there exists this literature attempting to do this. It's not clear to me whether those tasks, to the extent that they were good sort of measures of something for people, are also good measures of anything in particular for a language model. In the sense of measuring a property that would generalize to some other application that we care about. And so the way that I'm going to think about this is, for the moment at least, more as a diagnostic process to interrogate the model's behavior for a specific decision problem of interest, right? So you say, this is the model I care about, this is the decision problem I care about. You get a description of the model's behavior that's hopefully useful to you. And then whether that generalizes kind of, further than that in any sense will require like a lot of just kind of empirical work, and the answer could turn out either way. So with all of that said, here's the kind of the empirical framework that we're going to go through. So one, we're going to ask the model to report this subjective probability, just in natural language. We'll just ask it, given here's the question from a patient, or here's a patient with a specific set of features. What's the probability that the diagnosis is X? Then we'll instead ask the model to instead for a decision, right? Which here is like the sort of the actual interaction that it would have with the patient, right? The patient gives a complaint, and then the model, can choose to, to give a diagnosis or ask for more information or defer or whatever else. Third, we'll estimate a loss function, which would rationalize the model's decisions relative to the probabilities that it reported. And then finally, we will then try to do the sort of attribution of errors by simulating how the loss of a decision maker would change if you intervened on specific aspects then of one of these components, either the beliefs or the loss function. So just to say a little bit about how we do step 3, we borrow a discrete choice model basically. We model basically the agent as having a utility function that is specified by some parameters. So in this case of this diagnostic task, we might model the decision maker as having a cost for false positives, a cost for false negatives, and a cost for deferring, right, and not making a diagnosis. And so our goal now is to estimate the values of those parameters. Mm-hmm.
Are you restricting the proper scoring rules for your loss functions, or is this because you're assuming that that loss induced them to report their true beliefs, but a rational person, if given a non-proper scoring rule and eliciting probabilistic beliefs, will not necessarily respond with their true beliefs. I'm just wondering, are you making any assumptions and for any if it's a decision problem, there's an equivalent equivalent proper scoring rule for any decision loss if you're finding the loss for the decision problem, not for the belief elicitation. But it seems like there could be a proper scoring rule, but you're not restricting.
No. So we're not restricting to proper scoring rules. I do think it's difficult to say what it means to incentivize a language model to do something. So that's why I've been thinking a little bit about this. I'm not necessarily convinced that it's better to use a proper scoring rule to elicit the belief than it is to use some other.
Sure it is. I think just in principle, it seems like if you're trusting that is its true beliefs, it's anyway, it's hard to say what that is, what you are assuming, I guess.
So maybe we can come back to that, I think, as we talk about some of the results. Yeah, it's a good question. Chris.
Why estimate the loss function and not just provide it as a sort of, parameter in your experiment?
So because we want to understand if you just had the model have an interaction with the patient, right? What is implicitly sort of driving that interaction. And so then of course you can, and we do simulate trying to intervene in that, right? By giving the model more explicit direction about what you want, and then see if that shows up basically in this kind of loss that would rationalize its actions, right? That's maybe a measure of steerability towards what you want.
I see, but I guess conceivably you could say, here are the costs that are associated with all the different procedures that we might implement, and here are the benefits that they have, and I don't know, maybe in the sort of decision-theoretic frame, that's actually sort of the right thing to do.
Yeah. So certainly you could supply all of that as input to the model basically, but I guess what I'm saying is that you don't know basically the extent to which the model is taking the instructions.
I see.
Yeah. Mm-hmm.
How do you deal with cases where this hypothesis discussed for the loss is not expressive enough to rationalize even the behavior? So a case where the model says, I think it's more likely going to be 0, but it doesn't pick, I don't know which action it corresponds to. Right, so...
So discrete choice models then have an error term, which is an idiosyncratic shock to the utility.
Okay, but here's, then I'm curious, how often does that happen? Because I think the inference frame that there's the thing about asking you about your... So a specific number here is that in this task, the model picks the kind of strictly utility maximizing action per the explained component of the utility about 80% of the time.
Oh my God.
8, 9.
Time is accelerating. Okay, so basically we estimate this model. I think that's kind of sufficient to say. Now I'm going to walk through an example of applying this framework as I've sketched it out to a task of diagnosing the presence of structural heart disease. And so, so the first thing that we can do here is just kind of like descriptively, visualize the model's, elicited beliefs, its decisions. So the probabilities that it verbalizes are, here are correlated against the ground truth probabilities. They clearly have some signal, like they are related to the ground truth probabilities. But we observe this finding that a lot of people do, that if you just ask LLMs to report a probability, it looks really miscalibrated, right? It's like, it's very kind of overconfident, basically. And then we can ask whether its decisions, kind of at least are sort of directionally, consistent with what we would expect, given those verbalized probabilities. And we find that, the language model does diagnose yes, much more often when it reported a higher probability, no much more often when it reported a lower probability, and then deferral in some cases that overlaps with no, but is, directionally tending a little bit more towards the middle. Yeah, Nikhil?
For the decision problem, was it stated probability in its context, or it's like a new call?
Yeah, this is with 2 different calls to the model. Cool. So we can estimate the implicit sort of utility function. It looks like, to rationalize these decisions, you would have to care significantly more about false negatives, for example. And then what I'm going to do here is basically break down this sort of attribution of error as a sort of diagnostic tool for the model's performance if hypothetically you cared about a different loss function. So these are not, parameters that I think are particularly meaningful in themselves, but this is just, suppose you cared about something different. Then what is driving the model's, performance being good or bad relative to that?
Just really quickly, your state space and your decision space are the same here, or?
The decision space has an extra defer action compared to the state space.
Okay, but that's the only difference.
Yeah. Cool. So the way that we're going to do that is that we're going to start with the base model, which is just you give it the context, ask it for a decision. It gets some loss at the task, which is here just about 200% of the optimal, right? Like the Bayes optimal decision maker. Then we will simulate making optimal decisions with respect to a given set of probabilities and a specific loss function. So the orange bar here is simulating the optimal decisions with respect to the probabilities that the LLM verbalized and the loss function that we inferred for it. And so the difference between those is measuring some sort of internal inconsistency or that epsilon term being really large. Here it seems that's not a huge factor, right? If we strictly utility maximized with respect to this set of information we elicited, we would get the same loss at the task as what the model actually got. Then we can ask about what if we kept the same set of verbalized probabilities, but we optimized with respect to this nominal loss function that I stipulated we actually care about. And so that gives the yellow bar here, and the difference between that and the red bar reflects something like misalignment, right? Like with the same set of, like the same probability distribution over the state, but a different, but if you match the loss function exactly with what we wanted, how much better would we do? You can do the same exercise then with intervening instead directly on the probabilities themselves. And both of those things would seem to independently fix, much but not all of the gap in this setting. Another thing you can do with this is ask about sort of like partial kinds of interventions, right? So maybe it's really, it would seem hard to, just somehow do something that had the LLM, express like exactly the correct set of probabilities for this like specific data set and task and everything. But a sort of like a milder thing that you could hope for is that we could try to get the probabilities to at least be calibrated, right? There's like a ton of work now, like trying to get LLMs to have better calibrated probabilities. And so that's also something that we can then ask about here, right? We can take the same probabilities that are verbalized, post-calibrate them ourselves, and then simulate decision-making using the loss function that we inferred for it, right? So keeping the loss function constant while sort of intervening only on the probabilities. And it turns out that in the setting, that has a really minimal impact, right? So even though the probabilities that the model verbalized look super miscalibrated, that's not actually sort of causing, in some sense, most of the loss of the task, right? In the sense that fixing just that component would not suffice in order to actually fix the behavior. And then, as a final example here, another thing we can do in this kind of framework is ask how basically, if we have a potential intervention in the same sense on the loss function, how much of the potential gain from perfectly aligning the model are we getting out of that intervention? So here, for example, like the simplest thing you could do is exactly prompt the model and tell it, like, here is my actual loss function, and then hopefully it does something with that. But how much did it do with that, and did it actually did you succeed in some sense in getting the full benefit out of having a model that was correctly implementing your preferences? So that's now something we can try to get at by doing that experiment where now we prompt the model with the loss function and comparing its performance, and then seeing how much of that misalignment gap from earlier was closed. So in this setting here, I've broken this out by reasoning level because there's a big difference where this sort of prompting strategy closes effectively none of that misalignment gap for minimal levels of reasoning, and most of it for high levels of reasoning. And so, the orange bar here at high reasoning is not at the green line, right? It's not at 100% of the Bayes optimal loss, but it is most of the way to the sort of like full, intervening fully on the loss function. And so that indicates that in some sense there's not a lot of like additional juice to squeeze there, basically, right? Like if you had some more sort of like elaborate intervention in mind to fine-tune the model further to reflect just your set of preferences, that can have only limited impact unless it also is seeking to alter other components of the system as well. So there's so hopefully this gives a more concrete sense of kind of what I hope we can sort of basically get out of this decomposition, right? That we can get a benchmark that lets us say something basically about how much of bad performance at a task is attributable to sort of intermediate steps that would go into decision making that we might try to intervene on separately in different kinds of adjustments to training or prompting or whatever else. So clearly there's a bunch of directions to take this that we're working on, at least some of these. So we could look at multi-turn interactions and information elicitation, estimating a dynamic discrete choice model instead. We can compare alternate ways of eliciting these quote beliefs from language models, and we've done a couple of versions of that and gotten more or less similar results. But I think that this is absolutely like a real question that would sort of is pretty important to decide if this is a meaningful construct at all, basically. And then finally, of course, you can ask then whether any of these things sort of generalize beyond a specific decision task, whether you're saying something more general about a model as opposed to a specific model and a specific prompt, a single system applied to a single problem. But with that, I'll stop here and happy to answer any more questions.
Yeah, so that result that you flashed earlier, like where if you added the kind of correct beliefs, presumably like in the prompt, that didn't really have like a material impact on the sort of downstream performance. Like I guess it seems to me that there's kind of like two implications or two possible interpretations. One is that this is just this is not useful information for whatever reason.
So I do want to just jump in here that it's not correct versus incorrect probabilities, it's calibration specifically.
Oh, I see.
Yeah, so just pulling all of these things onto the line, but not improving the actual discriminative ability.
Okay, yeah, okay, I see what you're saying. I think the question still still holds, which is that like, so one interpretation is that it, you know, that information is just simply not useful for like this calibration metric, and the other is that like, well, the elicited beliefs are not veridical, like in some sense. So like it's not meaningful that like that's just so like, it's not meaningful in that sense. So I guess like given that, which of the two do you think is kind of the more likely like parse of the situation?
Yeah, so if you, I completely agree with you, right? This is like the sort of empirical question, basically, that controls a lot of whether this is a useful description. So I think there's maybe some ultimate sense of answering that question where you would try to actually get the model to be sort of, you know, for example, calibrated without changing anything else about it, which might be a very difficult thing to do, basically. But if you could do that, then that would give you one way of answering that question. If you want sort of my just sort of like anecdotal take about it, you know, based on running a bunch of, you know, kind of experiments here, or looking over, you know, Kerm's shoulder while he runs tons of experiments. I do think that there is enough kind of like internal things gelling together, basically, for this to be a useful description. And that is particularly the case with sort of more recent models, you know, that are trained more explicitly for reasoning tasks, basically, and have higher levels of reasoning, right? There is a much more sort of explicit sense in which, you know, the models, you know, like mechanistically even, right? Like it might sort of like in the reasoning chain, you know, be like, you know, asking itself basically about the probability of, you know, a positive diagnosis. Or even if it's not doing that explicitly, there is a much higher degree of consistency between different ways of asking it for that probability, and then its decisions sort of like, you know, correlating very directly with those elicited things.
Let's take the rest of the questions
Yeah.
offline. So let's keep the sanctity of a 30-minute coffee break. So we're going to start again at 11:15 a.m. and lunch is catered today. So lunch will start a little bit later, but it'll be catered. All right, thanks everyone.
Do you think LLM probability plus real loss is implementable?